So with this video, we're going to be talking about in section 4.3 polynomial division. We're going to be using long division and synthetic division. And we're also going to discuss the remainder theorem and the factor theorem. So some of you might remember how to do long division when you took this in either in high school or in previous course before. But let's go back over some of the tips as far as how to do long division. Now, I'll remember also when the directions say use long division, I expect you, especially on the test, to show your work, and we'll have a link for you to turn in your shown work for long division for your test. Now, any problem on the test that requires long division and you do not show the work, then you won't get credit for that particular problem. So just make sure you get a full understanding of how to do long division. So for this first example, we wanted to divide and determine if x plus 1 and x minus 3 are factors of x to the third plus 2x squared minus 5x minus 6. So what we're going to do is we're going to just go ahead and perform long division by doing x plus 1 first. So I can show you here. So here are the steps for doing long division. What you need to focus on is dividing the first term and the first term here on the outside. Take these two off to the side and divide them, and then that will be our answer on top. So I like to box them in to know which ones I'm using. So x to the third and x is equal to x squared. So I'm going to put my x squared on top. Now we're going to distribute by multiplying to each part. So anytime you get a number on top, a term on top, you want to distribute by multiplying to both of them. So x squared times this x here will give us x to the third. X squared times this 1 is just x squared. So the next step for doing long division is we're going to take both of these and subtract them. Now there's two ways of subtracting. Whatever you prefer is to subtract them, you're more than welcome to do so. A lot of students like to put this in parentheses and then distribute the negative inside to both of them. That way, this is just what it looks like. You have a minus out in front, and then this here gets changed to a minus once you distribute. And that way, you can just go ahead and subtract these and subtract these going straight down. And that's going to give you, these will cancel out, and this will give you just x squared. The other way of looking at it, like some students prefer, let's put everything back the way it was, is once they do the subtraction sign, they just like to talk it through. This x to the third minus this x to the third cancels out. This 2x squared minus a positive x squared gives us this same x squared. So whatever is more suitable for you to understand, if you want to distribute the negative side and change the sign, you can do that. Or you can leave it on the outside, but just make sure you talk it through and know that each term gets subtracted to the next term on the bottom. So once we do that, we're going to bring down the next number, the next term, which makes it minus 5x here. Again, we're going to box in and repeat the steps again. So box in the first term, we're going to box in this term again, bring it over to the side, x squared divided by x gives us x. Because these two are positive, we keep them positive. So then we're going to take and distribute, take this x here, distribute to both of them. That gives me the x squared plus x. Take them here and subtract them. I'm going to walk it through by talking. I'm not going to distribute the negative side, but you can if you want to. So x squared minus this x squared, they both cancel out. -5 minus a understood +1 will give us a -6x. Then we bring down this last one and make it -6. Then again, we do the whole process again, box in the first term, box in this term over here, bring it off to the side, and that's going to give us -6. So we put the whole -6 on top here. So take the -6, distribute to both of these parts here, this one and this one. This one gives us -6x minus 6. We're going to take both of those and subtract them. A -6x minus a -6x, they both cancel. And the -6 minus a -6, they also cancel. So once you, again, if you distribute them inside, just to show you one more time, this becomes a plus. This becomes a plus, so we don't need this anymore because we distribute the negative to both. If you see -6 plus 6 gives us 0, -6 plus 6 again gives us 0. So again, whatever you prefer, just remember that -1, that subtraction on the outside, either distribute or talk it through so you'll know. So this is considered to be the remainder of 0. Because we have a remainder of 0, this x plus 1 is considered to be a factor of x to the third plus x squared minus 5x minus 6. So that's one of the factors for the problem. So here we did the whole thing. We got a remainder, so we know x plus 1. So to determine whether x plus 1 is a factor, yes, it is. Now we need to do x minus 3 is at the factor. So we do the same steps, write it in, do the math here. This time we get a remainder of 24 once we finish off this problem. Because we didn't get 0, this x minus 3 is not considered to be a factor. So you have to have a remainder of 0 in order to be a factor. One other way of looking at it also, those of you that are proficient in factoring, if we take our answer here and factor it, x squared minus x minus 6. So let's do our factor. To get this x squared, I know I have to do x and x. To get this -6, I have to do 3 and 2. I can do 6 and 1, but that's not going to help us in the long run. Let me write this a little better for you. There. So we can do 6 and 1 to get this -6 here, but that's not going to help us to get this understood 1 here. A 3 and a 2, once I subtract them, it does give me a 1 for the middle one. So I think I'm going to stick with the 3 and 2. So because, and this, I'm sorry, this is supposed to be a plus sign. So because the middle one is a plus sign, the kind of the rule or the trick is make sure the bigger number gets whatever sign is in the middle. So if this was a minus sign, the 3 would get the minus sign. This because the plus sign, the 3 would actually get the plus sign for this one. And then this one gets the opposite because these are plus and a minus when I should multiply them gives me that -6. So we notice here our factors for this one here is x plus 3 and x minus 2. Notice that we was trying to look for x minus 3 in the problem. That's because we don't see it. That's how we also know this is not a factor. So the factors are for this one here is x plus 1, x plus 3, and x minus 2. So once again, if you are not proficient in factoring, you might want to review some videos or some YouTube clips on how to factor. But then again, you can still take this x minus 3 here, do your long division, and if you don't get this 0 here, then we know it's not a factor anyway. So in BioMath++, here are some what do the directions look like, and this is you have to write your answer a certain way. So for this one here, we're going to use long division to find the quotient. That's qx, which is here. And then we're going to use, and then the remainder, which is here, when p is divided by d of x and expressed in p in the form of dx times qx plus rx. So the answer needs to be written as the divisor times the quotient plus the remainder. So we need all these parts here. So back to the original problem what we just had, when we knew that x minus 3 didn't have a factor and it did have a remainder of 24, this is how it's written. So we have x minus 3 as our divisor. Our result, once we did the long division, the number on top of the long division bar is considered to be the quotient. So we have x squared plus 5x plus 10, and then plus the remainder of 24. So just to kind of go back to recap, here is the part up here. This is here. We have this answer here, and then the 24. So these are the three parts that we're going to use to replace into here, the divisor, the quotient, and the remainder. So you have to have multiplication. You don't have to put the dot here. You can just put them side by side, or the dot does not matter. Both of them will work as far as getting it right in MyMathClass+. So we have both of these multiplied together plus 24. So this is the answer that needs to be written in my MyMathClass+ when it asks for it in this form here. So if we do the remainder theorem check, remember our factors. We have x plus 1, and this is just a check. Remember our 0. If I say what is the 0 of x plus 1, you'll tell me the opposite, which is -1. So we have -1. We put this -1 inside for every x. 1, 2, 3. So 1, 2, 3. Do the math. We noticed that we already discovered that the remainder would be 0. That's what we found in the beginning part of this lesson. Then x minus 3, change the sign, get a positive 3, plug it in, and here is the remainder of 24. So this is a good check to figure out if we know that one of these two, x minus 3 or x plus 1, is going to be a factor by it having a remainder of 0. So here's just another example you can try. So go ahead, if you want to, go ahead before looking at the answer, give this a try. You can pause the video. And once you figure out, do all these steps here, you should come up with the answer to be x squared minus 6x plus 14 minus 31 over x plus 2. And here, this is how we write the remainder. Now, sometimes in MyMathClass+, they'll just ask you to put negative 31 as the remainder, which is here. But one of the proper ways to write it is whatever we're dividing by goes underneath the remainder. So we're actually divided it into here. So this is just two ways of writing the remainder. So once they'll actually have a little box for you to put in the remainder negative 31 in MyMathClass+, so you just put that in there. If they don't have one and you're doing some kind of book work or whatever, this is also another way of writing it. Here's another example using the long division, and we have to put it in that in the form of dx times qx plus rx. But this time, if you notice, we're start with x to the fourth, but there's no x to the third. We have x to the x squared, but we don't have an x. So it should go down in descending order. 4, 3, 2, 1, and then the constant. So here we have to remember, do not forget to fill in the missing terms. This is going to be important when we do our long division because you need those missing terms to help us continue on to find our answer. So you notice in red is this is the same problem, and I went ahead and put in the missing terms in red. And I put a 0 in front because this signifies, if I say 0 times x to the third, wouldn't this whole thing go away? And then 0 times x, this whole thing will go away because it's just 0. And that's left with the original problem that we just had in the slides, x to the fourth minus 2x squared minus 9. So we then go ahead and perform our same steps by boxing in the first term for each. Off to the side, we have x to the fourth, and that gives us x third. Then we come over to the top and put in x to the third, and then we're going to distribute by multiplying to both. And that's going to give us x to the fourth plus 2x to the third. And minus over here, we're going to subtract. So this is the reason why we put in a missing term, because they actually line straight up together. And so when we subtract, we have that missing term here, because a lot of students, they'll put this x to the third, x 2x squared 2x to the third underneath here, which it needs to be underneath here. That's why we need to put in that missing term. So let's go ahead and subtract. We know that both of these will cancel out. So we have 0 minus 2x to the third, which gives us a minus 2x to the third. Then we bring down this one, term, x to the third squared. We get our blue one, we box it in. Box in again the first term here, off to the side, x to the third divided by x. And that's going to leave you with negative 2x squared. Let's put it up here, minus 2x squared. Distribute to both of these first two parts again. That's going to give us with a minus x to the third minus 4x squared. So a negative 2 minus a negative 2 here, they both will just cancel out. And then minus 2 minus this 4, these two minuses make it positive. So we're going to take a minus 2 and add this 4 to it, and that gives us a positive 2x squared. So then we come on to the next term, we'll bring it down. So it'll be plus 0x. Box in the first one here, box in the x over here, 2x squared divided by x. And that's just going to leave me with 2x. So we do plus 2x. We distribute again, and we get 2x squared. And then that's going to give us 4x. So that's positive. We subtract them. So here these cancel out. So we left with a minus 4x. Last term, we bring this one down. Minus 9. We box it in again. So minus 4x divided by this x in front leaves us with minus 4. So we put minus 4 up here. So we take that minus 4 and multiply it to here into here. And we write our answer in. It's going to give us a minus 4x minus 8. We subtract them. We notice that again, these cancel out. So this here will leave us with a minus 1 as a remainder. So we have minus 1 as a remainder. We have x to the third minus 2x plus 2x minus 4. So we go back to our slides. So here's our remainder, negative 1. Here's our answer that we have here. So the form is going to be the first part when we took the first part instead and divided it by, we have x plus 2. We write it in front times our answer that we found on top of the long division minus the remainder. So this is the form it needs to look at when it asks for use the long division into expressing this px form. So the next thing we're going to talk about is synthetic division. So a lot of students prefer synthetic division because the difference between the two is with long division, we're using the variables. We have the x's all throughout the whole problem. With synthetic division, we actually take away the x's and just do the math with the coefficients in front. So one is with the x's, one without the x's. A lot of students prefer it. It doesn't look like this, but I will show you the way it looks like. But just to show you the same, we're going to be using the same kind of method and strategy. It's just we're not using the variables in this particular one for synthetic division. So for synthetic division, again, all we're using is the constants in front. So the first thing we need to do is we take whatever we're dividing by and change the sign. So this is an x minus 2, looks like a negative 2, so we're going to change it and make it a positive. Make a little backward L, And then on the top parts here, we're going to take the first number or the constant in the coefficient, the coefficient in front of the variable 4, -3, 1, and then 7. So take the coefficient in front, write it out, and then change the sign, make a backwards L, put it here. So the first step we need to do is take the first coefficient and just write it down in the front. Anytime you write the first one, just drop it down straight down here. Then we're going to multiply. 2 times this 4 gives us this 8. Then once we get this 8, we add them together. -3 plus 8 gives us 5. And then we just repeat the process all over again. Take the 2, times it by this 5 gives us 10. We add them two together. We always add. This time we're actually adding. In long division, we subtract it. So we add them, we get 11. Then we times this 2 by this 11 here. We get 22. Add them, and we get a remainder of 29. So this is what So here is going to be our answer for this problem. And let me show you the way it should look in the problem. Notice here we started with x to the third. We started with x to the third, and then when we write our answer, we're going to start this answer by dropping the exponent down one time. So this is actually going to be 4x squared plus 5x plus 11 with a remainder of 29. So let me show you what that looks like. So on the bottom, remember we had 4, 5, 11, and then we had the remainder of 29. So when we write our answer, our final answer is going to be, we're going to put in the x squared plus 5x plus 11 with a remainder of 29. So we always drop it down one exponent once we get our final answer on the bottom. So here is going to be another example. Notice here, look what's missing. We have a 3, we have a 2, but we're missing an x because we got to go down in order. 3, 2, 1, and then 0. So again, we're going to write in the coefficients in front. 2, 7, 0, -5. 2, 7, 0, -5. We have to write that 0 for the missing term. This is a +3, so remember, change the sign, make it a -3, backwards L. -3, drop this 2 down, so -3 times this 2, -6, add them together, 1. -3 times this 1, multiply, we can put -3, add them together, we get -3. -3 times -3 gives us a +9, add them together, we have a remainder of 4. So here we started with x to the third. So in our answer, we need to drop it down one to x squared. So 2x squared plus x minus 3, remainder of 4. This time in MyMathPlus, or in this example here, they want you to use synthetic division, but this time they give you f of 10. So what do we do with this 10? If you see an f and with a 10, you don't change the sign. You write this is a +10, so we're going to come down here and put a +10 in the backwards L. So the difference again, for this one, we want to change the sign. X plus 3, we change it to minus. If you see f of 10 or any kind of number here, we just go ahead and drop the number without changing the sign. So make a note of that. So we do the exact same thing. We have 2, -3, 1, -2, 1, and -8. So 2, -3, 1, -2, 1, and -8. We do the same steps, and we get to our remainder here. So notice here, when it says find f of 10, it's not looking for you to put this back into the equation. So normally we will say make the first one, we drop it down to x to the fourth. So it'll be 2x to the fourth, 17x to the third, and so forth. We don't need to write that whole equation, the whole polynomial function out for this one. All we're looking for when it says find the function is just the remainder part. So in order to get to the remainder, obviously we need to do the whole synthetic division, but just keep in mind, this is just the final answer that we're looking for this particular example. So here's another type of example. Determine whether 5 is a 0 of g of x. So this time they gave you the number 5. So what are you supposed to do with the 5? Keep it exactly the same. Do not change it. So basically, anytime you have an x minus 3 or x plus 3, that's the time we change them. If they just give you the number, we're just going to place that same number in there and do the same synthetic division strategy. But notice again, just another reminder, if you notice how it drops down, we have x to the fourth. There's no x to the third. X squared, there's no x. Remember, we have to put in those zeros. So for writing 0 for missing terms, we have to put those zeros in the problem. You get the problem wrong if you just put 1, -26, and 25 in the problem without the zeros. So just make sure you make a star of that in your notes. So once again, drop the 1 down, multiply 5 times the 1, we get 5, add them, we get 5. 5 times 5 gives us this 25 here. And then add them together, 5 times this -1 gives us -5 here, add them together, remainder of 0. So once again, we have the answer to be equal to 0 for the remainder. Now this is the most challenging type of example, because for this one here, they gave you the x to the third minus 3x squared minus 6x plus 8, but they did not give you what to divide by. There's nothing here to divide by. So this is where we need to do you might think to start this problem off to use a kind of guess and check. However, this can be very long and frustrating. How did it become frustrating? Because in your mind, let's just try x plus 1. We want to see if x plus 1, like I said, this part here was not given to you. So we need to find something to do so we can start our synthetic division. So we're just going to do an easy number like 1. Remember, change the sign. -1 here, we put in our 1, -3, -6, and then 8. We do our synthetic division. And notice here, we got a remainder of 10. So what does that mean if we have a remainder of 10? That x plus 1, remember our very first example in this section? If you have a remainder, then this x plus 1 is not a factor of this polynomial. So we actually just wasted a whole bunch of math when we chose x plus 1. And so we have to actually try another factor. Maybe we want to try x plus 2 or x plus 3 or x minus 5 or something like that to see here. But you can see how frustrating that can be by you just picking a factor without knowing if it's going to become a remainder of 0. So let's do an easier, faster way of figuring out what factors we can actually choose from. We need to look at the last number, or our c, in the equation or the polynomial function, and tell me what the factors are. So what two factors multiply to give you 8? We can do 1 and 8. That gives us 8. We can also do 4 and 2. Those are the numbers we need to choose from. So instead of looking at the whole listing of numbers, only use the numbers that are the factors of the last number in the function. So starting off, I know we did 1 and 8 and 1 didn't work, but we didn't try -1, because if we had -1 and times a -8, that's a factor and gives us +8, correct? -1 times a -8, those are factors that we could have used for this one. So we're going to try -1 this time. If we try -1, x minus 1, remember we change the sign, make it a positive, do the put down our coefficients. Do the math, and notice we did actually get a remainder of 0. So this means that x minus 1 that we chose is actually a factor. And then what is our answer going to be? X squared minus 2x minus 8 will be our factor. The last part we can do for this problem is we can actually just factor to find the last remaining factors for x squared minus 2x minus 8. Let me see if I can show you that real quick here. So here it factors to be x minus 4 and x plus 2 in our factors. So you could have tried first x minus 2 and x plus 2, or x minus 4 or x plus 4, because they're all factors of this 8. that's up here. And you notice that what would have actually worked? We already know the negative, the x minus 1 worked. So we could have chose 4, and we also could have chose -2. So these parts here would have still worked, even though when we tried these, they wouldn't work. But isn't this a lot better than choosing a whole listing of numbers? Well, all the numbers we have to choose from and just these few to know we're going to actually get a remainder. So that's just a helpful hint when doing these problems is make sure that you list all the factors of 8, including the negative one. So if you have a positive 8, remember we could have did -1 times -8. That's also a listing, and then try those to make this problem go a lot faster to find the factors. So this concludes section 4.3. If you have any questions, concerns, please let me know.